Hey everybody, in this video we are starting section 3 of the unit on exponential and logarithmic functions, and in this section we are covering the properties of logarithms, and we will be starting with the product property and getting into example 1 where we will use the product property to expand a few basic logarithmic expressions. Now the product property, without getting into the full nitty-gritty, it comes from one of the properties of exponents that we should all be fairly familiar with. Say you have something like b to the m times b to the n. When you have a common base, right, you keep that base and you add your exponents. So that relationship between multiplication and addition is what we're going to see at play right now. So when you have the log base, any base of b, of a product m times n, where m and n represent some sort of an algebraic expression, that is equal to the log base b of that first piece, m, plus log base b of whatever that n portion is. So that right there is showing us what the actual product property rule looks like. Now, just to point out before we get into some of these examples in the next few videos as well, if you are working on this problem and using this, right, and if we are going from this to that, that's called expanding. However, if we are going from this to this, that is called condensing. So all of that you'll see come up in directions, and you're going to have to read into that as you're doing any problem. So here we go. I have example 1, and we're going to really break it into a few little problems right here. So first one, use the product property to expand, that's the word I mentioned, each logarithmic expression. So the first one over here, log base 4 of the product of 7 times 5. Now it's possible that it's presented to you a little differently. Maybe it's presented to you as log base 4 of 35, and then you break it down into 7 times 5, right? So that's possible, but right now it's presented as log base 4 of 7 times 5. Now if I am going to expand like the directions say, that means I have log base 4 of 7 plus log base 4 of 5, and that's it. Done. That is the end of that example. Finito. Best thing you did all day, right? Lovely. Next example, we can take a smidge further. Let's look at what that looks like. We have log where there's no apparent base, but when there's an invisible base, right? So log of x, that's really equivalent to the log base 10 of x. And again, that is known as the common log. And it's sort of like how a square root of x is really the same as the square root of x within 2 in that spot. Since it's the default, it's the normal one we see all the time, we tend to not write it every time, you know, it's just the default, and we only really write it when there is something unusual, so not a base 10 or not a square root, etc. Just like a first power, we don't normally write the exponent, right? Okay, so anyhow, going from there, so we have the log, and I'm gonna have an invisible 10, log base 10 technically of 10 plus log base 10 of x. Now, while this is correct, we can actually take it a smidge further, because we can evaluate this little piece right over here, because that really is asking us 10 to what power is 10, and that answer is 1. 10 to what power is 10? 1. And log base b of b, we saw that property as well, it equals 1. So really we're left with 1 plus log of x. And we want to simplify these things further whenever possible. And that's the end of example 1b. And now we're going to just take a little peek at the checkpoint examples. So the first one here, log base 6 of 7 times 11. Well, that's log base 6 of 7 plus log base 6 of 11. So you can't drop those base 6s, okay? And I definitely think when working with log, it's good to make your ones with a little, at least a little hat on, if not the hat and the shoes, you know, the little serifs, because with the L's, the logs, they start to look like 10 or 109, like things get messy. So you definitely want to be careful. All right, and next one is going to be similar to example 1b in this checkpoint over here. And what is that going to be? We have log of 100x. So that's log, again, it's an invisible base 10, log of 100 plus log of x. Now this, how does this read? This really says 10, that's the invisible base, to what power is 100? And what's the answer to that question? It's 2. So our final answer to this, after we apply the product property and clean it up and expand and simplify all the way, 2 plus log x. And that is the end of that example. So hope this was helpful in getting you started. We're going to see a little bit more complicated examples in a video or two. We're going to do quotient property next. But if that helps you understand what the product property does, go ahead, give a thumbs up. If not, thumbs down. Questions, comments, concerns, requests, feedback in the comment section. Please check the playlist and the description box for more of what you might need. All right, bye for now. Adios.